Hey guys, and welcome to this new tutorial. In this tutorial we're quickly going to go over how to create a pipe generator based on input curves that you can use in Unreal based with all the materials and some extra effects. In this part we'll be going over the basics, how to set up the curves and create a digital asset from your curves, and from there on we'll just dive in and add materials and such. So right off the bat, I'm going to start in Houdini, and I'm going to create some geometry. Inside of my geometry, I'm going to create my first curve. And it doesn't really matter for this one, so I'm just going to select a few points. You can later adjust this. And then I'm hitting enter. I'm just quickly going to copy this one by alt dragging, and I'm going to have this curve in a subnet. So this is going to be my final HDA, and this is going to be one of my test curves. Because I dragged it in, I want to slightly change this so I can see what happens when I have different effects. As you can see the other curve inside right now. We want our pipe generator to be really versatile, so we don't really care too much if everything fits exactly on the grid, because we want it to work either way. Okay, so diving in here, what I usually do is I grab these three because I'm not going to need them. I'm going to color them gray, and then this one I'm going to hook up to a null node. And if I only view this null node, you can see we have our output curve. And the reason why I'm doing this is because eventually I'll be switching between curves that you create in an example Unreal, or that you create in your other settings. But I also want this tool to work if there's no input curve. So we're going to switch between those. So switch and have those. But I want this to automatically switch. So if there is no input curve here, then I want it to switch to this one. And the best way we can do that is inside of our switch node. I want to change the value. And it's actually quite easy. So I have this null here, and I'm just going to call this one check for points. So I'm going to use this null node, and I'm going to check if there are any points inside of it. And how I'm doing that is I'm going to write a fit expression here. So I'm going to type fit 0, 1. So it fits everything between 0 and 1. Then I'm typing endpoints. So I'm checking for the amount of points. And then I'm saying which node. Well, we just said that we're going to use our check for points. So I'm selecting that one. And then I want to set that between 0. Oh, let me show you this. 0 and 1. And then closing. And what that does is basically returns either 0 or 1, because it will always have either 0 or multiple points. So that way, if I have something in here, it will switch to this side, and if I don't, it will switch to 0. If I were to disconnect, say this one, then it will automatically switch, as you can see. So yeah. Oh, by the way, I just hit L, and that makes the layout for your nodes. I find it very convenient because it just cleans up your network a little bit. But depending on how your dependencies work on each other, it might really mess up your stuff. So either do this in the beginning of your networks and learn to work with it. Don't try to hit L after you've built like an entire system, because you won't be able to find where you're going anymore. Okay, so from this position, I'm just gonna create another null, and I'm going to call this in curve. So I know that if I connect this one to something, that will always be a curve. And I'm just going to color that one blue, so I know what's going on. I'm just going to give it a shape. By the way, Dokai, Pike and I decided to use specific colors for stuff. So if I go to our color menu, these blue ones are usually our input nodes. These are usually our output nodes, and then we usually grab green for our subnets, so we know what's like where to dive into, where something important is happening. And then we use some other colors for our control nodes or important nodes. I usually use red for material, so they really pop out, so I know, okay, this is for another software. the nodes that I don't really use, like these ones, I color them gray. So when I go out of my subnet and I select something else, you see they're all gray, so it looks like it only has one input. Yeah, so that's for the colors. You can just hit C for your color palette and Z for the shapes of your nodes, if you didn't know that yet. Alright, so we got our input of our curve. Then the second thing that I want to do is I want to create a circle, because this is going to be the backbone of our, or this is actually, yeah, this is going to be the cross section of our curve. But as you can see, it's quite kind of big, so I'm just going to decline or decrease the radii, and I'm going to set that to 0.05. I'm going to copy this and paste this here for now. All right, so we have a nice diameter of about 15 centimeters, which is about what we want for our curve. And then the next thing, I'm just going to place a sweep. I'm going to hook this up, and in my output, I'm going to set it to skin unclosed, and it's not going to work because our circle is still set to primitive, and we actually want a polygon. So that's the first thing that I'm going to do. All right, so we got our curve working. Oh, that pipe looks a little bit messed up. Okay, so this is a good moment for me to clean this up, and I'm just gonna place. I'm just gonna type it. It might just be convenient as well. So 0, 0. And then my second point is going to be going up. And then from there, then we have a nice straight curve. All right, and we have our subnet. You can see it's already working out quite nicely. In our sweep, we have stuff like angle fix. I'm just going to turn that on, so it actually scales the circle a little bit on these axes, so that you get like this nice view to it. All right, so that's our first thing. But I actually want to have a pipe that has nice, like rounded corners. And this is a possibility if this is what you're looking for, but I don't really like it. So I'm just gonna place a poly bevel, and I'm gonna run this over the original points. So we have guess from group. I actually want points, and then in our fixed distance, if I change these, you can see that our distance changed. And then if I'm like, okay, well, this looks like a decent value, then we're just gonna leave it to round. But the divisions, you can increase those, and you'll get like a really nice rounded corners. So these are all parameters that I actually want to change later on. So what I'm gonna do is I'm already gonna start off by creating this one into our very first iteration of our digital asset. So I'm just gonna hit right click. And then create digital asset, and what it does, it will pop up a new window, and I can basically name all my stuff here. So I'm gonna call this pipe generator, and then I'm just gonna type my version. So this is version 1.1. And then here I'm just quickly gonna save it. I'll just save it in my Dokai files here. It's just as easy for now. I'm going to hit accept, and then the name, I don't want it to be there. So I'm going to accept. And what it does, it pops up a new window. So we have our minimum inputs, and I don't necessarily need one, so I'm going to drag that to 0. And we also don't need any outputs for now, so I'm just going to drag that to 0 as well. So we have one input that could be there, and then no outputs for now, because it'll just be our final stuff. And I hit apply, and as you can see, our node here changes as well. So now we have one input. If I were to say, okay, I want to have 2 inputs, I hit apply, we'll have 2 inputs there. We'll probably use this second input later on in our tutorial series to create collision detection, so we can actually have a second input and see if there's any way to detect collision, but we might just keep it to 1 for now. And then at the parameters, this is where I want to have my interface with all the cool things going on. So I'm going to dive in, and I already knew that in our polybevel we have this fixed distance, right? So that's basically the size of the corners. So what I can do, I can just drag this one in there, and I have to rename all of these because I want them to be clear for my end user, because I might not end up using this tool myself, but give it to the designer or whoever works on it in game. So for now, this is going to be our corner offset, and then again making it clear for user corner offset. And as you can see, it's a very small number, so I want to lock this between 0 and 1 for now. Hitting apply, and you can see it becomes green. And of course, we also want the corner divisions. It will just come up as divisions, but we actually want as corner divisions. So we all know, okay, this is talking about the corners. Again, hitting apply, and that does it for now. Okay, then the next thing that we want to control is obviously the thickness of the pipe. And we're going to do that in our circle. So we have our radius, but we actually only need 1, because I don't want to, like mess too much with those 2 values. So I'm just going to look in this menu here, and I'm going to look for a float. I'm just going to pop that in here, and I'm going to call this radius. So this is pipe underscore radius. Again, pipe diameter. So what I'm doing is I'm actually changing this to diameter, because I think it's more convenient, so we have like our actual thickness. So I'm going to hit apply, and what that does is if I go out now in our subnet that we actually want to call our pipe generator, we have all these different versions. So I can grab my pipe diameter, make sure you don't make any typos, hit apply, and I'm going to copy this parameter, I'm going to dive in, and then in our circle I'm going to say paste relative reference, but I actually want to I want to multiply this. Alright. No, I want to divide it, I'm sorry. I want to multiply it by 0.5 in that case, because multiplications are faster than divisions. And that will give us, well, now it will give us 0, but if we go to our parameters, and we were to set this one to say, I want to have 15 centimeters, and hit enter, you can see that the radius becomes 0.05. And that's exactly what we wanted. And then from here, I'll just copy this expression, and I'll paste it in. So I'm sure that these have the same value. You could also drag this one in there and say to always take this value, so you'll make sure you have the same one, but this basically does the same. Alright, so I don't know why this still says divisions, so I'm going to rename this one corner divisions, hit apply, now they're all okay. I'm going to hit accept. Alright, well, as you can see, in the new Houdini 17.5, they turned on this bluish hue if your stuff has this backface cooling going on. So we know that actually our circle needs to be reversed. So I'm just going to hit reverse, place that in here, and that makes the normals all correct. Right, so we have our initial stuff set up. We have our polybevel going on, we have our sweep, we have our stuff here, we have these nice corners. And now if I dive out and I disconnect this one, you can see that it takes in the original input curve and it still works. So we got that going on, and that's pretty neat. So having done this first part of our pipe generator, where we can change our corner offset, and we can change our corner divisions, and we can actually change our pipe diameter. The next thing that I want to do is I want to create some flanges so it really starts looking like a pipe. And I'm going to do that starting from this curve. I need another polybevel. But in this polybevel, I actually don't want round corners, so I'm going to have none. And I'll still have the same value fixated. Basically what that does is it keeps hard edges, and that's exactly what I want, because for the flanges that I want them exactly at those points, so it always looks like there's two pipes connected to each other. And this is one of the connecting parts that we're going to make in this series, but we'll also add some other corner type pieces later on, and then we'll give the opportunity to switch between those pieces, because we actually want to give, as explained before, a lot of usage to the end users, the designers and such. So in the second polybevel, or after this second polybevel, I'm going to place a carve node. I'm going to set that from 0 to 1. That basically makes sure that our our general direction is all okay. So I turn on the primitives as well. And then I place, and then I go to the breakpoints and cut at all internal U breakpoints. It will actually give me primitives for each piece. And that's actually very convenient. That's exactly what we need, because I want to give all the straight primitives, so not the corner parts, but the straight primitives, I want to give those flanges. So after that, we're just going to create a group, and we're going to do a group range. And then we're just very easily going to select 1 out of 2. So if I see this one, and I'm going over the primitives, you can see it's selecting them. I'm going to give 1 offset, because I actually want the pieces that are eventually going to be the corners. And I'm just going to blast those off. So I'm going to copy this group, say blast, and from there, if I blast group 1, you can see we have our straight pieces. Then to make sure that everything in the normals is still okay, I'm going to create a polyframe, and I'm going to use the tangent as my normal. Alright, so the next thing that I want to do is I actually want to create flanges to put on those points. So I'm just quickly for now going to place all of this in a subnet, and I'm going to call this flanges. And like we said before, color this one green so I know what's going on. Then inside, I don't need these three, so I'm calling them dark gray. Hitting L to lay out everything nicely. I'm going to create an output node, because I always want to have these output nodes in my subnet, so I know, okay, this is the final node that's going on. And then again, I'm changing the shape and color, so I know what's going on. This was our input node, so I'm just going to quickly put that to blue. Okay, so that does it for these initial parts, which means that we can work on the flanges. And again, I'm going to type in circle, and actually I can copy the circle that we had before. So this one, I'm just going to copy it, because then I know I still have the right radius, although I have to update these now. So just have to copy this part, so we go out 1 level, because we dove in 1 level deeper, and then we get our values again. But I don't want the flanges to be exactly the same size as the pipe. I want them to be bigger. And I'm going to start off with giving them an extra. So we had a radius of 0.075 right now. So let's just add, say, I don't know, a few centimeters. Let's just add 0.025. Am I correct in this? 0.025. And again, I'll have to change that for this one as well. So what that does is it creates a slightly bigger circle than we had. One thing that I also want to change, and that will influence each other, is of course the divisions, right? So because this is a little bit bigger, I probably want to have a little bit extra divisions. I'm just gonna set this one to 16 for now. I also want to be able to change those later. So again, I'm going to hit my pipe generator and I'm going to say type properties, which opens the menu where I can drag everything in. And then in the divisions, I'm just going to drag it in. Now, what kind of divisions do I have here? These are my flange divisions. So I'm going to have that one in there as well. F_divisions. Apply, you can see it changes here. And we want to have a minimal. So the minimal will always be a certain value. I think for our flanges, we'll need at least 5. Even if we get like a very low poly version, if I'm going to drag this one down, 3 might work as well. But yeah, so it automatically pins it at 5, which is exactly what we need for this value. Alright, then the next thing that we want to do is we want to test it out, of course, if everything works. So we just want to copy these ones to points. So I'm going to hit copy the points. And I'm going to drag this in here. As you can see, it places it on there pretty neatly. But these are really thin. That might work for LODs. But if you're actually getting close to the object, you probably might want to increase the thickness a little bit. So easy way to do that is just hitting poly extrude. So poly extrude, place that under. And again, this is a value that we later want to be able to touch. We want to set the distance values of these. And the question is really, which way do we want to go? Because you can see they're all going in the same direction right now. And it's pretty much okay. But what I want to do is I want to create one, and I'm going to create another one on the other side. So I'm first going to focus on just a single version. So we have our circle. I'll set the divisions to 16 for now. Move to my polyframe. I'll set the distance. I want to have output back. Very nice flange. And let's say we give this a thickness for now of 0.005. It's pretty thin, but it's doable. Think of this as a really thick steel pipe, so this is a pretty thick layer as well. 0.5 centimeter is thick enough. And then I just want to make a high poly version, so I'm going to do a poly bevel again. And then inside our poly bevel, I'm going to set it to a very low resolution, or a very low number. So we got like this nice thing going on. And then ignore flat edges. It's kind of important because there are some edges that are, like not round. And then I'm going to increase this so we got like a nice feel. I'm just going to put it to 70. And that only chamfers the edges on these ones, but keeps this nice and straight. Okay, and then from there on, what I first want to do is, because UVs are obviously important, I'm going to create a UV project. What UV project does is it basically projects UVs on there. To visualize those, we're just going to type a quick UV shade or UV quick shade. If I drag that on there, we'll actually see what's going on. Okay, well, I don't have to change a lot in here right now, but eventually we'll add more. And then when it comes to the UV project, we'll especially add some stuff in the groups and the scale of the transformation. So the UVs here match up with the size of the UVs of the pipe. Alright, so we know this one is correct, so I'm just gonna delete this one. And as we saw before, we moved in our positive Z axis. Now I want to basically transform, and what I want to do is I want to transform that based on the poly extruded distance. So I'm going to go here and have this distance. I'm going to say copy this parameter, Let's say, we'll check which direction this is going to be in. So we know positive Z, it's going to be negative Z. So this one, I'm going to place my relative reference. And what that does is it basically moves it in the negative direction. So now we have our two flanges. And then if I just merge them together, you can see we have two nice flanges copied together. Perfect. So if I then copy those to the points and I view that, I actually get the feeling of actual flanges being there. They're nice and tight together. So now I can use all those information parts of the poly extrude, the poly bevel, the transform, that kind of stuff, and I can add those to our generator. So again, type properties, move in, and I actually want to have the possibility to change the scale of my flanges as well. So I'll create a new parameter, again a float, and I'm going to call this my flange, what shall we call it? Diameter. That's a good one. Okay, and then I'm in here. I'm not going to call it diameter because I want to add a small number to what we already have. So I'm going to call this flange length, and I'm just going to put in between brackets from pipe. So now if I hit apply, and I'm going to just put this to a very small number as well. Say, I don't need to actually give a number here right now, so I'm just going to hit apply, and then again if I go to our parameters, you can see that it showed up, flange length. Let's just keep it consistent. So we have our flange length, and now I can copy this parameter. If I go in here and I were to do another add, just add that value, then we have our total value based on a slightly bigger size from our initial pipes, but we'll still include like the possibility for us to scale those up a bit. As you can see, it immediately goes way too big. So what I'm going to do is I'm going to multiply this by a very small number. Oops, accidentally hit Control-C. And I'm just going to apply that there. And now if we change our values here, you can see that the flanges grow. Well, you can just play around with those numbers. Doesn't really matter for now what we do. Alright, so as you can see, we have our flanges, but flanges need to be connected as well. So we're going to add some bolts. Zoom out a little bit. I'm going to hook this one up to our output. Hit L so everything lines up neatly. Then the next thing we do is we're going to create some bolts. And I want the bolts based on the divisions of our circle. Right? So I'm going to copy this parameter. I'm going to create a new circle. And we'll just need a very small radius on this one. So we'll need something like 0.5 or something. So we got a 1 centimeter bolt. Enter. Okay. And what I want to do is I want to copy all my bolts based on the locations of these. So with my bolts created, or at least the shape and size of the bolt, I want to copy this circle, the original one, before we use the poly extrude. And I'm just gonna view this one and I'm gonna show this one. So we have our bolt, and I think this one as a primitive is too big. And for the bolt, I think something like 6 divisions looks nice. It looks like an actual bolt. And then what we want is we want to copy these onto each other. So I want to copy to points again. I'm copying these onto these points. So if I now view it, we see this one here. But as you can see, they now get placed on this corner edge, and we actually want to move them inwards. So what we can do is we can change the uniform scale a little bit, and that way, if we now look at our circle, you can see that they're moved in a little bit. And I'm just gonna make it even smaller. Let's put it to 75. Okay, let's put it to 80. And this is all up to your own standards. Really depends on what you want. Okay, so we have our position of our curves going on here, which is nice. But we still need to extrude our actual bolts as well. So again, we'll use our poly extrude, and for this I'm just going to use the exact same poly extrude that we used before. That way I'm sure that it gets extruded. And then again, I'm using this transform and this merge, and I'm placing that again in front of that. Copy the points. And as you can see, something goes wrong right now, and the reason is because these ones get a little bit messed up. So I want to cut this one. Alright, so now we have our bolts supposedly going in two directions. Am I right? No, it's supposed to be this one. So we have our initial pulley, then we have our copy the points, and those get merged in. Right, so that's the first way of initially fixing it. But we still need a little bit more offset, because we actually knew that in this one we use the poly extrude as well. So I'm going to use this poly extrude, and I'm just going to have this transform to be translated a little bit more. So I'm going to do this ×2. So now we have our offset on this side, and then I'm going to get another transform. I'm going to place that in here, and we actually want to go the negative version of that, so we get a little bit further ahead. And then you can see we copy them to the points. They look pretty good. Right, and then again, for the same these points that are copied, we actually want to copy them to these similar points here as well. I'm just going to copy this as well, and then instead of these ones, I'm going to have this one in there. So now they're actually at the same position as these guys. And then when we hook both of these up with one merge, we actually have our flanges. I'm just going to hit Shift R on this one, so I have that set up correctly. And then for this one, our second transform, I'm just going to remove this ×2 because we only need that extra distance. And then here in our output, F, we see we now have our flanges, and they look kind of weird and silly going on with or without the actual pipes. So I'm just going to hit L, so these nodes all get laid out pretty neatly. Then I'm going to hit normal, just checking if all the normals are okay. It looks pretty good. And then if I dive out and I add the flanges and the sweep together in one merge, put another output node, because that's what we want. I'm going to call this out pipe generator. So I know this is my final node. Again, I'm going to give it the right shape and the right color. Again, I'm hitting L, so it lays it out nicely. And now if I watch this, we have one big pipe. And if I switch this curve, you can see everything updates automatically. So this is the first step of our pipe generator, and we're gonna, in the next tutorial, we're gonna do a lot more. We're gonna add different corner pieces. We're gonna add a little bit of geometry. We're gonna go over the UVs for the pipe, and then eventually we'll add materials. We'll dive into Unreal. We'll clean up our parameter interface. But for now, this is our so-called versatile pipe, and you can basically do whatever you want. You could add some more points. So let's say I actually want to go further, so I want to go 2, and I want to keep it on the ground, and I want to keep it on the same xi, and then you see everything updates nicely. Now just adding these pieces works perfectly fine. So let's say we keep it on the same distance, same height, but we actually want to go -z 2 units. And there we go, we have our pipe. And then again, if I turn this one off, it will switch to the automatic initial setting that's in here. Okay, so the last thing that you need to do is, before closing this tutorial, is hitting the right button and then save node type. And what this will do is it will update all the changes that you made inside here and output it here. Thanks for watching. For now, this was Dokai. Bye bye.